So after assembling the second spin of the PC board for the 1702A EPROM Programmer, I ran into a few issues with the board, and I want to talk about those, and then we'll jump into KiCAD and actually fix those. So the first thing that might jump out at you up here is how this large filtering capacitor is mounted. It didn't fit into the hole actually cut in the board. The idea was for the capacitor to drop down into the board and kind of be centered in the board so it wouldn't have to stand up so high off the board. And even though I measured this and did everything I thought correctly, apparently the footprint I picked is still too narrow. I've got to decide how I'm going to deal with that. May end up doing a custom footprint, I'm not sure. That really, from an assembly standpoint, was the only issue I ran into. The board layout worked just fine, so I didn't have to do any of the wire bodges I had to get things to work before, so the schematic update I did certainly worked. A mechanical issue here that I ran into is I've added these 4 holes for mounting a cover over the top of this if you wanted to, except of course the handle off the ZIF socket here intersects there. It wouldn't actually close, and the socket could be spun around so that the lever was on the other side, but then it interferes with the programming LED up here. And I'm kind of trying to decide what to do with that. I may move the LED and current limiting resistor down to make room up here for the lever. To me, it doesn't really matter whether the lever is, towards pin 1 or towards, in this case, pin, what would that be, 13 over here. Again, not happy with that. I'd like to be able to mount on the front and the back of the board a cover that kind of covers this entire high voltage section up on both front and the back, just to make it a little bit safer in handling. I've actually designed a couple of PCBs that I haven't had manufactured yet that would provide that. But again, that design also needs this capacitor to mount down centered inside of the board. So a few assembly things I noticed as I assembled the board was the C401 silkscreen for this capacitor. Should have been down here, so I've moved that already in KiCAD. This is actually transistor Q14 to Q29, so I had a silkscreen error there, so I've corrected that. The 0.1 microfarad disc didn't get moved up here underneath this capacitor when I moved that capacitor. And the KiCAD and Open Hardware logos vanish every time, and that's because when I import the footprints, there's no footprints for those, and the silkscreens vanish, and I have to manually put those back on every time. So really the question becomes how to deal with this. I could potentially look for a larger footprint, and maybe that's the answer. I've got a pretty large footprint in here already. I went with this specific capacitor on DigiKey because it's got it looks old school. It looks like something more appropriate to the era. And the idea in this entire design was to use parts that would have been available when the Popular Electronics article was published, or was it Radio Electronics article was published on 1702A EPROM Programmer. And that's the reasons I'm using things like 8212s here for the EPROM address and the EPROM data latches. Every part on here was available back then, which was kind of one of the design goals, is this board could have been potentially manufactured back in the era from components that were available back in the era. So I want to stay true to that in this design. I may do a redesign of this in the future that uses more modern parts. I still like the idea of it being an S100 card that is used in the Altair. I'm kind of undecided. I'm kind of unhappy with this design because you have no way of verifying the program part. Here it's simply a programmer. It cannot do verification. But we'll think about that really kind of coming up here. So let's jump in here. I've got the project opened. You can open up the schematic. You've probably seen this schematic in previous versions. This is all drawn in KiCAD, but we'll kind of recap it here. I've got the S100 card edge connector here. The signals I'm actually using here are have connectors to them. Everything else is marked as unused. This is really for the Altair bus. It is not necessarily IEEE 696 bus compatible. It might work in those later machines. It's untested. We've got our jumpers here to select the base ports. We've got 4 hierarchical spreadsheets here, or spreadsheets, geez, KiCAD designs here. If we jump into the power supply, which is this section here, we will find that C401 large filter cap here. If we go look at the footprints associated with it, I'm just going to bring up the footprint editor right. There it is. And we let this refresh. We should find C104 here. That's the 470 microfarad cap. It's currently on a 38 millimeter by 18 millimeter by 14 millimeter horizontal mount. Capacitor. Can we actually? Yeah, we can view the selected footprint for it. We can see the one I've got here, and all I've done is drop that footprint in, and then I've added edge cuts on the PCB outlined in here to create the hole. And like you say, it is a little bit too small, which is kind of disappointing, so I may just go ahead and update the footprint on that. So let's find the through-hole capacitor footprints. It's currently using this one. You can view that in here as well, get the live view up. So we're 38 by 18 by 44. We could go to 42 by 23 by 45. I'm not sure that actually helps. One of the tools here will let me measure. Actually gonna, well, that didn't do me much good. Isn't there a measuring tool in here? Oh, there it is. So that's currently about 1.7 inches. Let me go back to millimeters here. I'm not really good yet translating millimeters to inches in my head. We can actually drag this up a little bit bigger, get a little bit easier to see. And let's take the measuring tool. Between the centers of the holes, it is 44 millimeters. So I was thinking the 38 millimeter down here was the length, and I've just discovered the 44 here is the distance between the pads. So the 38 must be the length of the capacitor, and the 21 the diameter. So that's good to know. I had these two values swapped in my head, and of course that makes no sense now that I'm looking at it. So we've got a larger footprint here that ends up narrower, and I'm not sure that's going to meet our needs. Let's do the same measurements. That gets me up to 45 millimeters from the 34. It certainly gives me more length between the pads. That adds 6 millimeters to the length of the capacitor, but it takes 2 millimeters away. No, it adds 5 millimeters also to the width. So that might be a good footprint. I guess we'll have to see what it looks like on the board. So I'm going to change that footprint to this guy, and he's been changed up here. And I think that was the only component that needed a new footprint. So let's go ahead and save it. We'll generate a new net for it here. we're in the right folder. Let's go back up a level here. Actually, we can close out of Schema, and let's open up the printed circuit board designer. This is the footprint we're dealing with here. You can see where I've moved the silk screens around here also in this design. So I did that off camera, added the missing footprints, etc. So that's already been taken care of. So if we import the net list, update footprints, I think if we uncheck, we're only changing the one. I think unchecking that will leave the silk screens in place. That, though I don't honestly know. Update the PCB. We can see where we certainly got a larger hole here. So we can see my original edge cuts. Really now need to look at the front copper. I need to delete out the front, or the front fill. Let's go ahead and look at the back and delete out the back fill. And take a look at the traces. I'm actually confused at the traces. The holes here didn't seem to move. Millimeters, I need the calipers. I want to measure from there to there. Yeah, that's 44 millimeters now. Actually, it did affect traces. What am I saying here? We can see that these traces are no longer hooked up. So it just happened to leave that footprint in the same position. Thinking about how to approach this. Let's do a bit of zooming in here. I think I'm going to move this trace out of the way here. Actually, I can't move that trace out of the way yet, as I need to get this all hooked up again. And if I move this to the top, he could come over to here. Actually, I think we can do this. Let's get rid of the bits here and go to the back. It's active. I don't remember what. Don't think those were 8 millimeter. No. Let's bump up the size. Those 2 millimeter, I don't think they were that big. No. I don't remember the size I used here, so we'll just kind of walk through. Still a little big. I actually want you to come down here. Let's do that again. That actually works. So we've reconnected that up. These grounds are all picked up by the flood fill. And these grounds should all be picked up by the flood fill. So I should have some room here now to move some footprints around. So let's go ahead and move this. Remove him for now. I'm going to move this footprint down a little bit. Move the silk screen down. Come to the front of the board. those back up. Like I said, the ground fill should take care of these. I'm going to move this footprint down a fair amount. I need to get that reconnected. Let's go ahead and move the footprint over where that becomes centered below. I want to continue this trace down to here. These edge cuts are going to need to get deleted and redrawn in. This jumper is only used to enable high voltage during the build when you enable the 47 volts to actually measure it. So, you know, this jumper's normally not touched after the board is, you know, the power supply has been adjusted. So let's go ahead and get some edge cuts back in. Edge cuts, I want to bring in active. I need to add graphic lines. I'm going to come just inside of the silk screen here. I'm going to hold down the control key, which will force that to snap to a straight line. Why didn't that work? Actually, before I do that, I see a problem here. I've got a little bit of edge cut sitting right there I need to get rid of. Let's add those edge cuts in again. I want you to come all the way to about there. This is where this always gets hard, is getting that actually. So what you're seeing me do here is I've zoomed in, because when I drag up you'll see a little white circle appear there, and if I click inside of that little white circle it will connect those edge cuts together. And that's what I wanted, was that entire frame being connected together. It's really easy when you're connecting here to not get under that little circle and then the edge cuts don't line up. So let's go ahead and do run DRC, courtyards overlap, bleeder resistor 1 and C401, D3 and C401, and D2. So let's zoom out here. This is basically saying these are now overlapping into the courtyard. For these, is that really a problem here? It's kind of sad that it thinks those are overlapping. I think I'll just go ahead and move these components around a little further away from the cap. See if we can clean that up. So I'm just going to wipe all the traces in here out. We'll redraw. Okay, yeah, I'm good with that. I'm going to move this footprint a little further over here. I'm going to move that part of the silk screen to someplace else. I'm going to go ahead and move. So BR for me is a bleeder resistor. Oh, I actually wanted to change the silk screen on this as well while we're here. This is just kind of a generic, looked to me about 20 to 33K. It's sufficient as a bleeder. It just bleeds off that high voltage. I'm going to grab all of these guys and I'm going to move them. Again, over away. Let's go ahead and do a DRC again, and we're going to see a bunch of unconnected stuff in the DRC now. Unconnected items, there's a bunch, but that cleared up the hey, we're overlapping, we're unhappy. So let's go ahead and get stuff hooked back up here. So I want to come back to trace, and he's going to get connected to there, to there. I didn't connect. And up to here. He's going to get wrapped around to here. These are grounds. They should get picked up in the flood fill. Let's go to the back of the board. We're going to bring him. Not happy with that. Let's do this one first. Oops. Redraw that. That takes care of those. We've got lots of grounds and power rails here that aren't connected. Hopefully the flood fill will pick those all back up. Let's go ahead and take a look at this in the 3D viewer. And again, it's drawn that capacitor body itself is very large, even though it's smaller than that. We've moved these components around to make some clearance over here. I think I want to move these down to make room for the lever. So we'll go ahead and do that while we're here. Let's get rid of, oops, that piece right there. Let's move him. I'll align him with the other resistor here. It just looks a little neater. Let's go ahead and move this footprint down. Boy, I have no idea how that got routed there, but we'll see if we can get it to route. I didn't pay attention to whether those were on the front side or back side of the board. First thing I want to tackle is this one. We don't need a super wide trace. We'll try this on the front of the board. And see if, wow, oh, that's really ugly. Let's try it on the back. That's even uglier. Well, I am going to put things back the way they were. And not actually delete these traces at this point. So let's just go ahead, move this resistor again. connect over to here. That fixes that up. This is on the back of the board. I want to move the LED down. Let's go ahead and move the designation. Want that segment gone. That segment gone. I'm not sure why that's so heavy. Oh, because it's +5. It got, wow, that really routed +5 up that way. That's sad. But we'll reconnect that up. Now I am very much still a novice at KiCAD. I think it's the LED moved, and that should mean the lever here on the ROM, and it sits up fairly high. We'll poke down through here. It'll have room. I don't like the fact that the word programming gotta think how to do this. I still want that LED to be labeled. This really isn't going to fit here very well. No, there's no real way. Let's bump these up a bit, make it a little bit larger. Drawn on the silk screen, front solder mask, front silk screen. Get that centered a bit better here. Back to a line tool. You can notice the little white circle popping in and out there. Not thrilled with that, but you know, somebody using the board when the red LED's on, it'll definitely be an indication something's happening. I think that's everything I wanted to do. Let's go ahead and go to the back of the board. I want to add flood fill. That doesn't seem right. Oh, I'm on silk screen, that's why. Back of the board, flood fill, and it's going to be on the back of the board, and it's going to be connected to the ground net. We can just hold down the control key here again and basically just grab an outline of the board. I kept this up a little bit away from that edge connector intentionally. Let's go ahead and do a DRC again. Unconnected items. That's +5, pad 2 of CD6 on all copper layers. So that's CD, or the capacitor decoupling. Let's go ahead and close that. We're going to come to the front of the board. We're going to do a fill again. And we're just going to get... Actually, something to note here is I wasn't real accurate. I just drew basically on top of the edge cuts here for the silk screen, because the silk screen will get automatically brought in from the edge of the board and even amount all the way around. So I don't have to try to click right there to draw that in. It just kind of happens auto-magically. Took me a while to realize that. We're on the front of the board. We're going to do a fill. We're going to start basically up here someplace. It's the front, and it's the +5 net. Hold down Control, drag over to this edge of the board, drag down to about the same spot here. And when I move over to the left here, it automatically basically finishes the box. And just by double-clicking here, it'll go in and automatically basically do the the full square fill. So let's see if the DRC check is clean. Got one unconnected item. Pad 1 of D8 on all copper layers. Pad 1 of R19. You can see that I missed that right there. So let's back that off. Let's go to the front of the board and get that reconnected before the fill. Oops, I don't know why that didn't take. And DRC check again, the other. No, that was just it. I just missed that. So let's go ahead and flood fill again. Front of the board, flood fill. Basically here, connected to the +5 net. Control keys down, basically over to here. Being a little more precise there, double click. Run the DRC check. And we have 0 unconnected items, and we have 0 problems and markers. So, there's some things to note here. There was actually a trace on the front. Or is it on the back of the board? There's actually a +5 trace on the back of the board. Actually, I'm going to save at this point since I'm happy with the DRC. I'm going to hide the front of the board. We've got this +5 trace here that isn't needed because the flood fill on the front, I think, took care of this for us. So I'm going to remove this because I think it's unnecessary. And I'm going to flood fill the front again. Let's go back. We're going to redo the flood fill on the front. I thought there was a way to refresh the flood fill. Maybe not. There's what I'm trying to delete. And I'll just redraw that in again here. I don't know if there's a way to refresh it. Flood fill. Up here. The +5 net. To here. Just double click. Run the DRC. Okay, so we actually didn't need that trace, which is nice. So I'm going to reflood fill the back now. And, well, actually it took care of that already. So the backside ground actually filled that in during the flood fill. So that unnecessary trace there is gone. And if we look at this +5 and look at the front of the board, well, the front of the board, we can see that the +5 here is hooked to the +5 flood fill. You can see the thermal release on it there. Really, I'm okay with that. We haven't changed anything electronically. Let's go ahead and edit down here now. And this is going to be B. We need to do one more thing. Front silkscreen. They were actually maintained this time, so I'm happy with that. So I've got the KiCAD logo, the open hardware. This will be released open hardware. A little bit of white here to write something onto if you wanted to. Let's go ahead and view it in the 3D viewer. Do I really have enough clearance there? Let's go back to the photos and take a look at what it looked like in the photo. I'm sorry for jumping around here in so many folders. Let's get a look at the board here. So this socket is on top. I've got a wire wrap socket that the text tool socket is plugged down into. I don't have any of the bases. I think, there may not be enough clearance for the base of one of these sockets to actually clear these resistors. Those two resistors may need to get moved out a little bit as well, just to create more clearance. But with the lever down, I'm confident now I have enough room here to clear the LED. Right. So think about kind of like having the programming LED by the handle with the handle down. And the LED is flashing. It's kind of saying, hey, don't touch me. So that's not a bad thing. So let's consider moving these two resistors. They shouldn't be hard to move. Probably just pull them over tighter in this direction to create more clearance. I wish I had a proper footprint for the text tool socket here. I'm kind of guessing, but I'm feeling like those are too tight. So let's go ahead and get rid of the flood fills again and zoom in here and look at what we could do. We can certainly move that footprint. That's 65. Can remove that segment and that segment. Back to, I think it was that trace. I want to draw on the front of the board. Okay, it snapped to it finally. That gets that hook back up. I don't need, oops, that line segment or that line segment. Let's go to the back of the board, line tool, snap to it. Not super thrilled with that, but that's fine. It's not going to hurt anything for what this is. We can get over to here on the back side of the board. And this really doesn't need to be routed up around. Well, we need to move this resistor next. So let's go ahead and move this resistor. It looks like it's pretty square there. Move the silkscreen label. Okay, that is coming over to prog there. So let's get that drawn back in. Oops. Doesn't need to be a super thick trace. I don't remember the diameter of that. It's even narrower than that. Gets that hook back up. I think I'm actually going to cut this old trace out and put it back in. The front of the board. Take you, oops, need to be that heavy. I'm actually going to pull you around this side. Rid of that line segment. We're going to be drawing on the back. Heavier line. That's interesting. I suspect there's a nubby there. There was. I'll go ahead and put that back on the front of the board just because that's where it was. And we will hook you back up to there. It's still lost. Oh, okay, that's +5. I don't need to worry about that. Hopefully the flood fill will still pick that back up. We've cleaned this up over here a bit, actually, which is nice. Now we have that really large trace up there that is no longer there, which kind of footprint R66 and D8 overlap. I was afraid of that. Too close together here. Do I really care? I'd like it to be clean. I don't want to get much closer to the edge of the board here. Hell, crud. How much do I have to move you before you don't overlap anymore? Okay, that was enough that we don't have the footprints. Schematic back to the front of the board. Oops. do that almost every time. And now, of course, I want to move this one over so we have alignment. No, I want to get rid of that line segment and that line segment. And I'm going to move you into about alignment with the other resistors. I'm hoping that net's not too close there. Drawing on the front. Clean up silkscreen issues. Move the 47K. Move the 47K. R65 still lines up there. Don't really have that might be better. Paths. Right now looking for track too close to pad. I was afraid this right here was going to be an issue. And it is. That's not what I wanted to do. I want just that line segment removed. And just that line segment removed. Drawing on the front. I'm actually going to kind of force the routing myself. DRC again, and that should clear that up, and now it's just unconnected items. So back to what we did last time. We're going to go to the back of the board. We're going to do a flood fill, connected to ground, connected to someplace here, kind of above the edge connector. It doesn't have to be too precise. Oops, it didn't take. To ground. Don't know why it didn't take. That was kind of weird. Well, doesn't like something. We're on the back of the board. We're flood filling. To the ground. Maybe I'm accidentally clicking outside of the edge cuts. See, this is the stuff in KiCAD that it's like, why all of a sudden can't I do a flood fill? Or is it doing it, see, the confusion there? Let me see if I can remove the flood fill. So I didn't have the copper layer exposed. So even though it was doing the flood fill, I couldn't see it because I'd unchecked back of the board. To ground. Those are little gotchas that just get to me. I get so confused about why all this, this was working. Why isn't it working now? Well, that was obvious once I figured it out. There's the ground flood fill. Let's just do a DRC. That dropped to 19, which I think was the same count as last time. Let's come to the front of the board. Flood fill. Connected to the +5 net. Oops. A little bit. That's my own fault. Up in that corner. +5 net. Over in this corner. 2 down here. And I need to drag in a little bit to DRC. 1 unconnected item. Okay, there was a missing VGG connection. Remember I commented there was a trace that ran up around for VGG that seemed to be missing, so I'm going to get rid of the two flood fills. I just missed it, so VGG comes to here, so that really can be routed on the back of the board. I knew I was missing something. Okay, that's better. We'll do this once again. Flood fill on the back. Click. Pick ground net. Here. Trying to decide what's a reasonable height here. We'll call that good enough. And just a note, the two pads here are grounds over here, and they both have a large trace that comes off, and they've got multiple vias to stitch them together, and then that just got picked up into this entire ground fill there. So, the fill is picking up stuff that it needs to. There's the front side of the board where those stitchings occur. So it is doing the right things for me here. That comes to the +5 net. To about the same height. It doesn't need to be critical there, but another DRC. 0 unconnected items, 0 problem markers. We've got a good DRC. See what we've ended up with. We've added a little additional. So assuming the text tool socket is kind of in that size, there should be enough for a normal text tool base there, I hope. And then the socket stands up slightly. The lever's definitely up here. I'm liking more and more the fact that the lever is up against the LED. There's an indicator here for pin 1A that should stand out there. We've definitely got a larger hole here. We've gotten through the DRCs. happy with this. It's going to be, it's called B. I've actually archived the A and the original layouts as well. They get archived away, but there was no real assembly options. When I assembled the second board, I literally used the silkscreen indicators to know where to put parts. And that was intentional to make sure that the indicators were correct. If we go back to the photo, I'll point out one other thing here that is just irritating. If I can find the photos, did I close it? It's been irritating to me, and that is once again kludging in a couple resistors here to get to 35K, because I keep forgetting to order 35K resistors. I thought about putting in a second set of footprints where you could put in a 35K or a 3.3 and a 2.2 like I did here. Either way, I think I'm just going to leave it like this and just expect a 35K to be dropped in here. I don't know how, it called for 5% and 10% capacitor, so they want this to be pretty accurate. It's not super accurate on either one of the builds I've done, but I'm just not worried about it. A little longer is not going to be as bad as a little shorter pulse width for programming. But I think, we're in pretty good shape here. So it's going to cost me another $100 to spend another set of these, because I can, the minimum order quantity is 5, which kind of sucks, but it is what it is. The perfectionist in me really wants this right. So I think I will wrap this video up here. Maybe you learned something. Maybe you enjoyed watching this. Maybe you didn't. Anyhow, either way, I'll wrap this up here and we'll talk soon.